Hello everyone, my name is Vinicius and I'm going to present my work entitled Visualization of Crowd Contamination Simulations using Immersive Virtual Reality. So we start with the introduction. Smart cities are urban centers capable of collecting data from the population that can improve different aspects of the city. Studies conclude that the smart cities and simulation data can improve urban planning and consequently people quality of life. In particular, simulation that allow the integration of real data can improve this type of analysis. However, most analysis tools or simulations use data dashboards to visualize this data, which sometimes may not be enough to analyze so much data or generate insight to solve the problem. Virtual reality is an application that can facilitate the visualization and analysis, and is allow the 3D elements to be visualized and manipulated in a virtual environment more easily and intuitively, such as using a control to pick up and drop objects and increase the engagement of the users. So, based on this scenario, this work developed an application for immersive data visualization of medical centers to help the analysis of development of new strategies. The application allows the user to visualize the data from crowd simulations, monitoring the number of people concentrated in a specific location, and inform when a location has been reached the maximum capacity. After search for works on visualizing simulated data, most of the application found only provide 2D visualization. None of the available tools offer an immersive 3D visualization option, which could make the analysis process easier and more understandable. For this reason, this work aims to implement a visualization and interaction of crowd data in an immersive virtual environment. So the application developed in this work makes it possible to visualize and interact with simulation data using an immersive virtual environment. The system was implemented in Unity 3D, running in a MetaQuest 2. Here is an overview of the application. So the application receives an OpenStreetMap file, a file with information about region that will be used in the simulation, and the data generated by the simulator. With all file loaded, the virtual environment is displayed in the MetaQuest 2, and the user can interact with the virtual object and analyze tools. The OpenStreetMap file was exported using an online tool that allows you to select the region of interest and export it in an OSM file. The region file contains the list of nodes that will take part in the visualization. Each node has an ID, a lat-long coordinate, a description of the region, a type like hospital, restaurant, gas station, etc., and the max capacity of the region. So the last file contains the data generated from the simulator. For this work, we use Lodo Simulator. The data has been adapted to allow the visualization of path of each crowd displacement. Each line has the frame of the event, or days, the origin and destination of the event, the crowd size, and the amount of infected. To generate the 3D map based on OSM file, an open source GitHub project was used to create the building of each region in the virtual environment. The project also creates all routes inside the region selected. The user interacts with the application using two controllers of MetaQuest 2. In the application, the user can interact with the interface to configure the visualization of the simulation. The timeline is controlled by rotating the virtual clock, and the user can view the number of people in each region by clicking the region of interest. The user has some analytic tools that can be used while visualizing the data, such as a line graph to display the number of people in the region over time, and a pie chart displaying the percentage of infected people in relation of the all selected region. The application also has a way to inform the user that the region has reached the maximum capacity by displaying alerts on top of the 3D model representing the region. The region can be selected by clicking on each model or by using a cube to define a selection area. So here we have a demonstration of the application. So the user starts in a virtual environment with a 3D map instantiated. The 3D map can be positioned anywhere and its size can be changed. Each build can be selected and information displayed in if it's in a OSM file. Here is a virtual clock. And after starting this visualization, each displacement of people is represented by cylinders. So the green cylinder represents the healthy people, and the red cylinder the infected people. When the user selects a region, the data is displayed in the line in a pie graph chart. Each graphic is updated as a region is selected. You can change the size of each graph. The user can highlight the regions in the graph by pointing the beam at the region, and they can change the order of listing. Here is an example highlighted region. Now they change the listing. Here's another example of change the listing, the pie chart. And the timeline can be accessed by using a clock hand. So they can move forward or backward. Here is an example of a building reach the maximum capacity. Okay, so in this work we implement a prototype for visualizing data from crowd contamination simulations in an immersive virtual environment. The prototype allows the 3D map region to be loaded and region of interest to be instantiated to monitor the crowd behavior. Some analysis tool was created to allow the user to visualize the data of specific regions of the map, enabling a better understanding of the overcrowding behavior and allowing the insights to create new strategies to solve this problem. For future work, we plan to conduct user studies to validate the usability and performance of the application for analyzing data, and implement new analysis tools to improve the potential of the application. So, is it? Thank you for your attention.